Welcome everybody. We'll just let everybody kind of settle in here. So we have Dragon Innovation teaming up with RE3D. So I've got CEO Scott Miller, Samantha Snabes, and Matthew Fiedler here. So we'll just let everybody get settled in, and we'll get going shortly here. You guys both in Houston, Samantha and Matthew?
I'm in Houston, actually, where the factory is located.
And I'm in, I split my time between Austin and Puerto Rico. So I'm in our Austin office right now.
Excellent.
And yeah, I was in PR briefly last week.
Oh, nice. What part of Puerto Rico?
We're in San Juan in Parallel 18 or 18 co-working space right now. And then we have systems all over the island, including one at Engine 4, which is their big IoT lab. So if anyone's listening in Bayamon and visiting San Juan, they should definitely check it out. It's like the center of gravity for all the IoT stuff on the island.
Oh, cool. And what's your strategy, or why are you in Puerto Rico? What's the strategy behind that?
Yeah, so that's where we do what we say is applied research. So a few things that are notable about PR, it's still part of the United States. So your cell phone works there, and then there are different incentives. We haven't leveraged those to date, but we received 40,000. It's a carbon copy of Startup Chile to explore having an office on an island where 85% of your goods are imported. There's high unemployment. They have a huge manufacturing nexus. A lot of the big pharma companies do their manufacturing there. NASA hires more engineers from University of Puerto Rico, Maya Wez, than anywhere else in the world. They have a great architecture program as well. So you have really creative people that don't want to leave their island. They get manufacturing. They have to import goods. And so there's a big push right now towards entrepreneurship. So we're uniquely positioned. Ironically, you know, we're a spinoff of Engineers Without Borders, NASA Johnson Space Center, and had this vision to make a toilet-sized 3D printer that could be piloted by waste. You know, thought a little bit about disaster resiliency scenarios. And then 1 month after we got our footing there, a month and a half, Hurricane Harvey hit our factory in Houston. And then the next month, Hurricane Irma hit, clipped Puerto Rico. And then 2 weeks later, Maria hit. And so while we were without power for 5 months, Engine 4, the co-working space, was connected to the national grid and hosted us as refugees to look at the printer that we already had on the island and the consumables to see what people would make. We donated it and designed for needs. So kind of accelerated our investigation into disaster response applications, which has opened up some unique opportunities, allowed us to scale on an island where the landfills are closing in 1 to 2 years. So as we look at now piloting this ability to create a circular economy and to use waste in manufacturing, we're uniquely positioned next to the big brands that are putting metric tons into their landfills that are now full or are closing, and then also around, you know, this opportunity for new job creation.
Oh,
Very cool. Very cool. Well, thanks a lot for everybody for joining us. We're going to get started here. So welcome everybody to the live Q&A. We're going to be talking about sustainability in manufacturing with Dragon Innovation RE3D. So I just want to welcome everybody from, you know, abroad, but you know, would love to hear a brief introduction for who we got on the call today. So Samantha, if you wouldn't mind starting.
Sure, I'm Samantha. I'm the Catalyst and co-founder for RE3D. I got started with Matthew when we were both supporting NASA Johnson Space Center and about a decade ago, and had this crazy idea to make a toilet-sized 3D printer, eventually that would be powered by garbage.
Wow, that's great. Matthew, if you want to start.
Yeah, so my name's Matthew Fiedler, and I'm CTO and head of all things technical and mechanical. Before we got started, my background is in everything from tool and die to manufacturing engineering to biomechanics and biomedical engineering, and did a brief 6-year stint at NASA's neuroscience laboratory just prior to founding RE3D. So super excited.
Excellent. And Scott, if you wouldn't mind going.
sure. So I'm Scott Miller, the CEO of Dragon Innovation. And my background is as a mechanical engineer. Always been able to work on a bunch of robots, from robotic tuna fish for the US Navy to full-size walking robotic dinosaurs for Disney. But as it relates to manufacturing, I really started cutting my teeth at iRobot in the early days when I was put in charge of trying to figure out how to manufacture the Roomba, and moved to China in the early 2000s, really having no clue what I was doing, and trying to figure it out from scratch. And we ultimately did. We got to the point where we could build about 40,000 Roombas a week, and made about every mistake in the book, but somehow that which does not kill you makes you stronger. And we got pretty strong at the end of it. And what we're trying to do at Dragon is help other companies that have a prototype be able to navigate that journey safely from one to many. More recently, we've really gotten interested, and we've always been passionate, but trying to make it more actionable with an understanding of sustainability. So I'm really excited to chat about that today, and I'll share what I know, but I think I'm going to be learning a lot from Samantha and Matthew as we dive into this important topic.
Excellent, excellent. And so I am Andrew Hall. I head up marketing here at Dragon Innovation. So I'll do my job of pitching our company to give everybody a quick understanding of what we do here at Dragon. So we are Dragon Innovation. So we are a manufacturing partner for companies who are building complex products and need help with the NPI process, or new product introduction process, all the way through ongoing production. So we can help you whether you're in the earlier idea phases or proof of concept with our content and educational resources. So all the way up through when you have that working prototype, BOM and CAD files, and are ready to go from that, like Scott said, one to many in high volume manufacturing. We can help you find that perfect partner to help get your product produced on time, at quality, and at the cost that you're looking for. So Samantha and Matthew, I'd love to hear a little bit more about Re3D.
Sorry, I just muted myself.
Oh, all good.
Yeah, so we got our start in 2013 when Matthew and I were working to get together and volunteering with Engineers Without Borders, and in our travels in Nicaragua, Mexico, and Rwanda, we saw a few things that were pretty common. We saw a lot of plastic waste, a huge frustration on the dependence of aid and imported goods that might not be the wrong cultural fit or couldn't be maintained, and these really long supply chains, high unemployment, and more importantly, we saw that the people that we met were really brilliant. So Matthew was involved with the maker movement at the time and had one of the first open source printers. I'd had a life science company previously manufacturing a hardware device using 3D printers, and we'd been exposed to it at NASA. So Matthew was really keen when he saw the opportunity now to bring down some of those cost barriers to 3D printing. He was like, guys, the future. So it didn't take very long as a serial entrepreneur to put it together and start to wrangle our friends with this concept to make what we called a toilet-sized 3D printer, something that could actually print things you would use, because the groups we spoke with weren't as interested in maybe iPhone cases or smaller widgets that were popular at their time. They were really focused on lower limbs, birthing stools, composting toilets, things they said that were at the human scale. So with the dimensions of the composting toilet, we set out with this vision to make Gigabot, which is cost per scale, the most affordable industrial printer on the market, with this vision to later modify it to print from trash. We were fortunate that Startup Chile gave us $40,000 to quit our jobs and to try and make this concept a reality. Lucky for us, they had a booth at South by Southwest in 2013. So right after Bree Pettis from MakerBot gave a talk, the doors opened, and Matthew had managed in 8 weeks to make the Gigabot, which is our flagship technology, in Houston, and drive it over to South by Southwest, where I launched it on Kickstarter while I was in Chile. And TechCrunch came by and announced that 3D printing was bigger than a bread box, and we hit our goal in 27 hours and raised $250,000. And have been fortunate as a proudly bootstrapped hardware manufacturer made in the US to now be in 50 countries, and to have also had a lot of community support through National Science Foundation, Creator Awards, to continue to support the R&D innovation to print from trash. And Matthew can speak more to that, but we are doing it from both Pallets and Flake. It still has a long way to go. So we're selling the units in beta and excited to co-develop with the community.
Excellent. Very, very cool. So now that you all know a decent amount about us, I like to see, hear a little bit more from the community, see who's out there, see what people are working on. So I'm just going to launch a quick little poll to see who we got there, and then we'll go from there. So our first one is just asking if anybody's currently working on a product or developing something, or just, you know, have an idea or just here for the fun. All right, I'll just give us 10 more seconds here. I always find these fascinating. Time's up. So it looks like we have 70% of you are working on a product, and 30% of you are here for the education. So that's great. Now we can just check in, see what your role is at your company.
This is so fun.
Yeah, that was interesting to see. Alrighty, so it looks like poll is done here. So we got about 40% engineers, a handful of designers and founders, and then a lot of others. So we'll figure out what those others are at some point. Great. So now that we've got all those, you know, logistics and things out of the way, I'd love to just hop right into this. So again, we were very appreciative of everybody submitting their questions prior to this. We got a lot of really interesting and topical questions for this subject. So we're going to try to power through as many of these as we can. You know, just on this topic, I think everybody did a really good job of keeping things topical. So very impressed with all the questions. So the way that this is kind of going to work was we'll have a primary person. So I'll alternate between, you know, Samantha, Matthew, Scott, and then they'll feel free to kind of, you know, riff off of each other's answers and really create that great discussion vibe. So first question for Samantha: given the current processes and supply chains that exist, what practices as product designers are concerned, or as product designers are concerned, are sustainable?
Yeah, I think we could probably have an hour-long discussion around what the word recycling or sustainable means. But I think for purposes of this, we can maybe vector it for me, and it's thinking through kind of that life cycle analysis of a product and finding ways that it can continue to be enduring. And from a component standpoint, so that hopefully it never touches the landfills. Either you can dissect it or keep it going. And then I think the life cycle analysis and looking at designing for permanent use or long-term use is also really critical. We struggle with this. Matthew can speak more to the actual design of our printer and why we chose to make it modular and to have extrusion components and quality parts in terms of the durability. In terms of the output of the printer, this is something I think about a lot with our designer Mike right now, because we're working to design goods printed from waste or virgin materials. And so one thing that we've been looking at lately from a tactical standpoint is how do we ensure that things we mix with that are quote unquote sustainable? So for instance, in the first version of the furniture you may have seen us bring to CES that was made from recycled water bottles and then excess wood from Habitat for Humanity's Restore, we had used adhesive and epoxy to glue in the joints. And it didn't take very long as we participated in the sustainability forums in Austin for someone to point out that that wasn't really truly sustainable manufacturing. Yes, we used to reclaim materials, but the adhesive makes repurposing it very difficult. So in the second version that we took to 3D Experience in Nashville, we incorporated screws. So we were thinking about the ability, you know, if it breaks, or say we want to grind up the plastic and print something else, or need the wood for another application, we can just screw the two components together and then remove it at a later date, with the hope that all those three materials could be leveraged. So I think designing for sustainability involves, in short, the thinking through how you use sustainable resources, but then also hopefully how you have a product that just continues to add value and is more permanent, and or if it needs to be dissected or evolved later, doing it in a way that allows for that.
Excellent. Matthew, do you have anything
Yeah, I would.
on that?
Yeah, for sure. And I think it's probably also helpful. And I'd like to add to that, just framing what do we mean by sustainable. And I think that some people look at this in much different time frames. So an activity or a process that is sustainable in a short term is not necessarily sustainable in a long term. And if we truly think about sustainability in the longer term, I'm talking the 100 years, 300-year plan, right? Because we can do anything for a month or a week or a year, but as we think about what's going to happen many years down the road, and that's the long-term thinking I'd like to challenge people to adopt. And I think a little bit of it is informed by my background. I grew up on a farm in Iowa, and farming, you have to be sustainable. You depend upon that land year after year after year, and as a small business, you're responsible for so everything that goes into it, just like any other small business owner. So it's really your livelihood. You live there and you breathe it. And I think that's deeply ingrained in myself. And I look at the practices, and directly to your question, you talk about the processes that we have in production, and then also the supply chains that exist. As we start to look at the sustainability of our supply chains, people are questioning, does it make sense to have these long supply chains, right? So the carbon footprint, if you want to measure it in one way, of transporting these goods long distances, does it make a lot more sense to have distributed manufacturing, right? So as we analyze these supply chains and start to identify, if we can distribute the manufacturing and have more localized, then you can also be more customized and tailored to that community or that segment of the society. So I think we're finding a lot of these advantages in distributed production, and that does disrupt the supply chains. And I think that's one of the things that, if you look at UPS and FedEx and DHL, they're putting a lot of thought, some very serious thought into what is the future of production look like as we start to disseminate the production and spread it across many different regions.
Excellent, excellent. I think we covered actually a lot of what I was going to check in with you all next, with basically the recent developments of innovations in sustainable manufacturing. So I'm just going to jump right to another one. So this one's for you, Scott. So how do we start to implement sustainable practices in designing and collaborating with the stakeholders as we go into in manufacturing?
Yeah, so I think we really have to look at it holistically. These are really complex trade-offs we're making. And I know when I started, I used to think, I'd use the analogy of the alphabet, where A is, we come up with an idea, our customer does, and then Z used to be, for me, it's delivered to the customer's hands, and it's either sold through retail or direct. But I think that's an incomplete picture of it. It's really Z is when the material goes on to the next product or ends up in a landfill or is burned. And if you have to look at the whole soup to nuts thing, then you start to get into really interesting trade-offs from how much energy is used to derive the material from the earth in the first place. And then if it's recycled, does it take more energy to transform it into the new thing versus harvesting virgin material again? And then, so that's the energy equation. You could look at it from the carbon footprint from the landfill, which is personally my pet peeve. One of the things I've struggled with is, over the course of my career, I've probably helped companies build 100 million products, and I'm pretty sure 100 million of those are going to end up in the landfill. So how do we measure that and change that? But I think the trick is to understand through transparency, what are all the different steps in there. And there are some good tools from the life cycle analysis or LC analysis, which will help you understand from an energy standpoint, other tools like the EPA waste management hierarchy, which looks at sort of the best thing is to reduce and reuse, and then it works through recycling, composting, energy recovery, treatment or disposal, which would be landfill. And then I think they didn't put it down there, but even worse would be the stuff ends up in the environment on the side of a road. So trying to think through all these different facets are really important conversations to have up front when you're designing a product, so that you can influence the design to make it much more environmentally friendly at the end of its life.
Sure. Samantha or Matthew, if you have anything else to add, otherwise I'll just hop right into this next question. So,
I think the only real quickly, the thing in general, as we look at the design process and how do we build for sustainability, is if we can build products in general that last longer, right? So if we look at, if it takes it has a much longer service life, that's a much more sustainable product. So I think that's an easy win right up front from the design conceptualization stage. If we can convince all the stakeholders that, okay, let's go ahead and put an extra little bit into this product, and the lifespan will be a lot longer, I think that'll be a win-win for everyone in the end.
Yes. Yeah, and I know it ends up it really impacts the way you design a product. So I know from the first Roomba, the original one was designed to last 200 hours. And then later on, we got it up to 2,000 hours. But that required fundamentally changing the architecture to include replaceable modules, because we knew the motors just couldn't survive that long. And that in turn, impacted the mechanical design, the electronic design, the logistics, like how do you create simply the packaging for a wheel module and send that out, the processes and infrastructures. But it's one of these where, as we say at Dragon, the early decisions cast really long shadows. And it's so much easier to influence stuff in CAD, whereas once you've got it out in the world, it's much harder to make these changes once they're tooled in steel.
Mm-hmm.
Very interesting, very interesting. So I have a question here that I have tagged by Samantha and Matthew as, we really want to answer this one with an exclamation point. So I'm excited for this one. So regarding material selection during the design process, any tool you recommend, especially to pick more sustainable, recyclable ones? So I'll let either Samantha or Matthew, feel free to hop in.
I'll let you go first, Matthew, and then I'll chime in.
So if we look at the material selection, I talk again about the longevity, and I think is kind of a key point to sustainability. There's a lot of that enters into the equation of the energy equation that Scott talked about earlier, and a lot of those variables, as you start to divide by time, they start to become smaller and smaller and smaller. So time really is the overriding factor in sustainability, and it influences the equation quite heavily. So materials is important to longevity, obviously, and the ability to reuse those materials. So whether you're using more durable materials up front, say I have a cast iron cook pan that I use at home regularly, it's probably 80 years old, right? That's a pretty sustainable product. If I can cook with the same pan, and it'll probably last another 80 years, no problem. So the material selection is hugely important. As we look at the ability to break those components down at the end of its life cycle, the cast iron, that can be remelted and reused almost entirely and quite easily in a recycling process. And sustainability leverages heavily upon the 3 R's, right? So reduce the amount you're using, to reuse and recycle. And the interesting thing is that even on those materials that we consider like the plastics, right, which are gaining a lot of traction in the recycling aspect, but typically people think of them as a low value material, which is changing quite a bit now with the engineered plastics that we have coming into the market. But I think, so the really interesting thing for us is the studies that we're seeing that you can create a 50 to 70% energy savings by utilizing recycled materials, including the recycled plastics. So that energy equation certainly is on the side of reusing the materials.
Yeah, I think in sustainability, we focus a lot, at least right now on the consumer level, be curious to see, Andrew, what you and Scott think. We talk a lot about like reuse, which is super important, or just reducing consumption. The thing that sometimes is just breaks my heart, and other times I think it pisses me off a little bit, is when I visit all these factories around the world, and you know, we won't point fingers, but having an industrial printer, we sell a lot to governments as well as to small to very large manufacturing companies, and we get insight into their operations. And I can literally take a meeting about, you know, our standard filament-based printer and you know, the ROI and opportunity to do on-demand manufacturing, and or be giving a lunch and learn on the ability for them to create more products on demand so they source less internally. And I have watched in front of my eyes, and I have pictures after pictures on my phone, especially in Puerto Rico, of rooms and bins that have filled up with post-manufacturing waste and scrap right in front of my eyes. So all that excess material that goes into, you know, making, I don't know if it would be the same for a Roomba, but a lot of products have just a tremendous amount of scrap, not to mention all of the packaging waste that is produced, and just bringing in that raw stock or shipping the materials out. And it gets really compounded, say, if you were a pharmaceutical company or you were a bottling company, and a requirement around the fit, the form, or the type of material changed, and now you have like a massive amount of inventory of clean and virgin material that no longer has value. And to me, it just, you know, from a manufacturing standpoint, thinking about sustainability, like, that's just not cool. Like, I would submit to you, and it's funny, we work with a lot of big brands, and they're all just starting studies and working with analysts and trying to quantify the amount of waste they have in their own supply chain internally, that it's possible that that amount of waste may exceed even the consumer waste that we talk about a lot. You know, at Re3D, we focus on water bottles because people get it, and it's a great conversation. And, you know, NSF's given us about $1.5 million to make that happen. But the reality of it is, like, what I see just leaving the roads in Puerto Rico where some of the manufacturers are, and going out to docks to be shipped, that amount of waste going back and forth every day is just astronomical, and it may exceed the consumer output. So I think as manufacturers, we have to really think about our processes in terms of how much waste are we creating, or are we just filling up in our trash cans every day? And can we reduce that in the way that we responsibly make products that have a really long lifespan?
Yeah, I mean, it's certainly, for me, the thing that turns my stomach is just looking at the single-use packaging. And it could be whether it's, we love Amazon, like probably most people, and it's so easy, but, you know, there's going to be a whole bunch of cardboard and then inflated airbags and stuff like that, which cardboard is pretty recyclable, but the airbags are not. And then the amount of energy it takes to ship it versus, again, all the plastic, impossible to open clamshell packaging that's used once and then thrown away. The number that stuck with me is that only 9% of the global plastic is actually recycled, which is
the 1950s.
Yeah, it's crazy. Like, you know, I always feel so good throwing away or recycling the plastic, putting it in the bin, but, you know, only a small amount of that is going to show up in another product. Most of it's probably just going to end up in landfill. So I think I'm kind of fooling myself most of the time there, which is really frustrating.
I think it's been interesting. We've had conversations with some of the big brands focused on the ocean initiatives. Mm-hmm. And as they've begun commissioning studies now, they've backed it up and said part of their ocean initiative involves just diverting their own waste from ever getting to the landfill and then the ocean. Because, you know, we can clean up all the trash in the ocean, but we're still dumping it in, and it's coming from somewhere. So how do we cut back on that? And a great example is, I think as manufacturing companies, we've all gotten a pallet of goods that has saran wrap around it. Think about how much of that alone goes directly to the trash every day.
Right. Yeah, it's mind numbing. It's we've really started paying attention to what we throw out and what we recycle this year, and it's influenced our behavior that we'll stop buying stuff. I know with the new SWORD initiative, where China and a lot of Southeast Asian countries are no longer taking the world's plastic and paper to be recycled, it's creating some interesting pressures to figure out what to do with it. One thing we've been thinking about, or at least me, probably not my family, because they're more logical, but just keeping all of our own shit that we buy and putting it in my backyard. Because I know if I did that, I would definitely buy less stuff, and that would be generally a good thing.
I threw out my trash can 4 months ago to see what would happen. It really, it's troubling when re3Ders crash at my house in Austin. And I put it on the kitchen counter.
Okay, so you just have all your, like, walk me through what happens with your trash. Do you just not buy stuff that's gonna,
It's made me very aware, and I'll have an internal rule. I know this is disgusting, Matthew, that it has to sit there for 2 weeks before I'll throw it out. And I look at it. It's like I just felt like I had to walk the walk. But yeah, I threw my trash can away.
That's awesome.
Which is really unsustainable. It was a terrible idea.
Excellent, excellent. Well, so since we're starting to talk a little bit more about specific products, Scott, I got one for you. So do you have some ideas on improving sustainability manufacturing without compromising the quality? So small steps to start taking?
Sure. Yeah, and we truly believe that, if you can influence the design up front, you can have a much bigger impact than trying to work it in later. But one of the, so when we think about products, or at least as I think about them, they basically have four main components. And again, one of my main interests is landfill. So they've got typically the cardboard or paper that's part of the packaging. They've got the plastic, which would be the clamshell, potentially some metal parts, and then the printed circuit board or PCBA. And then for each one of those, we look at, how long does it stick around and how much good stuff is in there that you can, harvest later. For recycling, generally you want to be able to break it down into the different recycling streams. So separate the printed circuit board from the plastic, from the metal, from the paper. And as you're thinking about designing a product, right now, we use a lot of joining techniques in design for assembly that are impossible to really take apart after they've been joined. So things like overmolding, which you might see on a toothbrush, or ultrasonic welding, or solvent bonding. Once you make those joints, they're permanent, and therefore it can be very difficult to break the product down into its basic ingredients for recycling. So we're thinking more about snap clips and screws and things like that, which are a little bit easier, but maybe ultimately things where the consumer could just pull a string or something and the whole product falls apart, and you can put the plastic in the plastic bin, the PCB someplace else, and the metal in a third bin, to make the recycling much easier. With a lot of these, there's paper is pretty well, most paper is post-consumer content and is pretty straightforward to recycle with not a lot of energy. We talked about plastic, only 9% is recycled, but it very much depends on what type of plastic it is. If it's PET, which is type 1, or water bottles, there's a lot of demand and a lot of supply for that. So that's a lot easier to recycle. The things like ABS, which is type 7, the other category, is easy to recycle, but it's mixed up with everything else. So thinking about how can we separate that, because it's a pretty high value plastic, I think is a key thing. Metal is very valuable, and also it doesn't degrade over time. So that one should be recycled. And then you get to the fourth category, the printed circuit board, which is kind of a mess. Like, if I have my facts right, in 1,000 iPhones, there's something like 35 pounds of gold, if you look at all the boards, but it's just really difficult to extract that gold because there's just a little bit in every phone. And it's a very painful process using hydrochloric acid to be able to release it. And I don't know the answer to it yet, but trying to think about how we design boards to make it easier to either reuse the components or extract them or break them down. So those are sort of some of the early things we're thinking about, but just how do you not assemble it, but how do you disassemble it, and designing for that.
Excellent. Kind of continuing on the manufacturing triangle topic here with sustainability. So this one is for Matthew and Samantha. So what are some of the best ways to incorporate sustainability into consumer products and find sustainable manufacturers while still keeping product development and production costs affordable? So getting into the cost aspect.
So a lot of the costs in your products, as Scott said earlier, everything is that long shadow that comes off of the design process, right? As we start to have this next generation, the younger generation that is much more sustainably focused, as they're moving into roles that they're making decisions in designing products and putting products to market, I think this is a naturally gravitating towards thinking about what is the end of this product, what happens, what's that cradle to grave process look like, and what is that carbon footprint, what is the LCA of these products. So I don't know how many people are teaching to that end as we start to look at universities and we start to look at education. But I think it's a naturally occurring phenomenon, which is really good, that people are generally incorporating that sustainability into it. And it entails everything from a lot of the points that Scott just gave, you know, looking at how is it constructed, how is it manufactured, and can it be deconstructed and in an easy way. Living in the world of plastics, Scott talked about the overmolding and some of this. What really frustrates us quite a bit in some of the plastics we'd like to recycle is, say, multi-layer food packaging. So think about all of those laminated plastic packages that have the foil on the inside and a plastic on the outside. These are things that are very unsustainable, and there really is very, very little you can do with this. So while we may be able to fish them out of the ocean and clean up our landfills, there's really nothing we can do with it besides burn it, or you know, the end of life is very difficult for some of these materials. So starting right up front and thinking about the cradle to grave aspect in the design process is super important.
One thing that Matthew, I think, did a really good job with early on is recognizing, just as he saw with the desktop printers he bought and prior to start, and that inspired Re3D, was that, you know, this technology, this 3D printing technology is evolving very quickly, and it's manufactured. So, you know, sometimes we get a little bit of flack for Gigabot maybe not being as aesthetic as other products. But Matthew and the team intentionally makes it modular by design, because I think one thing you have to think about as manufacturers is you're going to be versioning all the time. And we can have a separate webinar about how you do customer support with that and inventory holding, but I think it does relate to sustainability, and that you have to think about, like, okay, how can I create something that our users in 54 countries can version up and stay current without them having to buy another system and then see this in the landfill. So, you know, we have the upside of being an open source company, but you'll recognize a lot of the design features of Gigabot are not just modular, but use resources that are common to manufacturing so that it can be hacked. And we provide to our customers the opportunity that if you don't do it yourself, you can work with us, and there's always a path to upgrade. And that's a commitment we make. And I think, you know, that's how we've kind of overcome the versioning conundrum and being socially driven and sustainability like leaning. But I'm sure there's a flavor of that for a lot of different industries. And then in terms of the supplier question, you know, that's a tough one. I have an MBA in supply chain management, and I wrestle with this one every day. We, you know, we're without a salary for a long time, and then discount our time, and our team does, because they're very mission driven. But we do a lot of manufacturing in-house for this reason, allows us to quickly iterate and shortens that supply chain. And so then for what you can't do in-house, it's really incumbent on you know, the small business early on, or the manufacturer, to build relationships with local suppliers, and always more than one, because things happen and they can be in high demand. As you were just talking about earlier on the call. But thinking through, you know, as a first step, can you do some of it in-house in a more sustainable way? And then can you source locally? It's interesting that just through on-demand manufacturing, whether it's 3D printing or other tools, I think it was Gartner a couple years ago had created a study that said that they estimated that by like 2050, 50% of goods that were traditionally sourced, maybe from overseas, could be manufactured in-house or locally with new techniques and technologies and the current trend. And just by that alone, they predicted that CO2 emissions from the transportation long tails would be reduced by 20% globally. So it's just a really interesting, like, second and third offset. But I think when you're getting started, you can look at, can I do it in-house? Can I source locally? What is the opportunity there? Or for repairability, will my customers be able to source locally if I'm not able to support that?
Excellent. I think that's a great description of that process. So this one for Scott, are there any accreditations or standards for meeting ESG goals for manufacturing? And if maybe you just define ESG too while you're at it.
Yeah, sure. So ESG is environmental and social governance. And there's, so I tried to do a little bit of research on this, and California has a Supply Chain Transparency Act, which a lot of clothing companies are, looking at really seriously. My understanding is it's more focused on human trafficking and slavery, which is a really important issue, especially in manual manufacturing. But my hope is that sort of the beginning of many that will come. The transparency there is the key word, and I think kind of the foundation on which sustainability can be built. So understanding what do your supply chains look like, and as we've talked a little bit about, they're actually a lot longer than you might think they are, especially as you start flow charting it all out and thinking, just about the amount of energy and effort it takes in packaging to get the goods from one to the other, to the other, to the other, to the final consumer. So trying to understand that transparency is key. There's a bunch of, again, more on the clothing and cut and sew area, but there is the Fabric Institute has a rating, I believe it's from 1 to 100, sort of looking at how transparent all of the different brands are. And Adidas scores quite well on that. I'd love to see if we could bring some sort of a similar methodology to my world, which is consumer electronics, and be able to provide a rating for the different brands. And I think it could be a really interesting competitive advantage for companies that are more sustainable. I know, again, we haven't thrown away our trash can yet, but I'm really tempted to.
Don't throw it out.
We'll recycle it, reuse it. But yeah, I mean, we would certainly pay a little bit more or a lot more for a company that we know is taking better care of the earth. And I think if there was a third party that provided some sort of a framework to judge how different companies were doing, that would be a really critical thing. But I haven't seen as much in the area of consumer electronics. And I don't know, Matthew or Samantha, if you're aware of anything out there.
Yeah, Scott, I think the thing I see a lot with ESG is also known as the triple bottom line, right? So for a lot of your founders and that are on the line listening, they're looking at potentially having investment, right? And so we see it a lot in the investment world as well, is that we're starting to get a lot more socially responsible investing. So if you're potentially looking to raise money, the investors see this ESG rating as something that is going to give them a better return on their money, right? Because we know that sustainability is going to pay off over the long term. And that's, they have short-term, mid-term, and long-term goals with their investment as well. I think some of this also ties back to even back to the UN sustainability goals. So that the sustainability development, the SDGs as well. So I think we see it from a manufacturing perspective and a product perspective that may be driven even a little bit by the investing world.
Yeah, I've been amazed. Right now, just with the threat of a recession, leading a manufacturing company, you just have to pay attention to that. So I have decided that while there's a concern, I'm going to apply for one opportunity a day, whether it's like a pitch competition or a partnership opportunity or a grant, just to kind of keep that line open. And if anyone listening is a founder and wants the links to where I go to search for opportunities in this domain, please reach out to us. We love sharing. But I've been amazed at how many of those applications, or even for speaking bios, like they have a drop down that forces you to show how you align or what SDGs you align with. So it's great to see for those companies just getting started that they're becoming aware of SDGs, have to do their homework on each one and how they're aligned with that.
Excellent. I think for this next one, we touched on a lot of it. So we were talking about the main pollutants. So I know, Samantha, you mentioned a lot of, waste that you've seen coming off the lines, and then we've touched on a little bit of the carbon footprint. So I'm just going to jump ahead to this next one. Is using recycled material for products, so PET, et cetera, actually more sustainable? So what do the constraints on the use of recycled plastics look like from a manufacturing standpoint? So I'll just offer it up to to each one of you as well.
Yeah, so some of the studies we see coming out of MIT and some of the recent reports looking at that carbon footprint and looking at the energy requirements, and specifically I'll speak around the recycled plastics because that's more of the world that I live in. They're seeing a 40 to 70% reduction in the carbon footprint using recycled materials. So it doesn't mean you have to do 100% recycled. There's a lot of ability for us to start to mix in, whether it's 10, 20, 50% recycled content. I know that the large plastic manufacturing companies are looking at modifying materials and creating new materials that help with that compatibility aspect as you're starting to mix in recycled plastics into your products. And it's something that we are looking at sourcing more and more recycled content every day. You know, we're not at 100% yet, but we want to get as close to that number as we can with all the materials that we offer our customers as well.
Excellent. Anybody else want to jump in, or I can skip to the next one?
And for the plastic, I think it depends a lot on what type of plastic it is, which we touched on a little bit, but the water bottles are generally made out of peat, there's a huge demand in that most people use plastic water bottles. So there's a lot of supply and a lot of demand to be able to reuse them. But for some of the more esoteric plastics, then there's just not the infrastructure to be able to harvest that and reuse it. So it's very resin dependent.
A material that we often get asked about is just the plastic associated with discarded electronics, for instance, and so much of it. We have a couple Gaillards from Ingram Micro that we haven't tested or figured out how to cope with, or I think one Gaillard. Yeah, to your point, Scott, there's a real need for infrastructure around a growing list of plastics that people have recognized are just sitting around that could otherwise have value. It's very regional too.
So actually, to your point, Scott, this is really, as people learn a little bit more about Re3D, they'll see that this is a focus of that building that infrastructure, right? So PET may be the #1 recycled material out there, but who says that you can't recycle the others? So as you start to look at thermoplastics, by nature, they can be reused. And so our focus in developing the technology that we have with our Gigabot X platform and allowing people to recycle right on their factory floor or right in their community. So looking at that small granulator and looking at, okay, so now we've granulated the material, we put it into the right format, you can put it back into the machine, and then essentially seeing a 3D printer is like a little mini factory and being able to produce products right out of it. So specifically speaking to that, if we can provide people with that distributed capability to recycle anywhere, I think that's a win-win.
I would say we talk a lot about products, just to throw this in before I forget, it was in my notes. What makes me excited, again, kind of fixated on that manufacturing conundrum and the scrap, and my first job was in a factory in Detroit, is the ability in terms of the double or triple bottom line to use that plastic for internal need. And I suspect that the real opportunity is not that sexy, but it has a big upside. So for example, some of the use cases we've looked at in Puerto Rico with manufacturing companies that have maybe tons of bottles or caps or scrap that they're putting out every day in a pharma application, may have potential to take that and then use it to create, say, plastic bins. They may even be GDP compliant that could cost over $1,000 to source and ship to an island as they stand up a new line. So looking at closing that loop. Another application that came up recently when we were at the SolidWorks event, the event with SolidWorks in Nashville is, and we've heard it a couple of times now, is whether or not it might actually make sense to print plastic pallets. There's a crackdown on wooden pallets, we're told, in some of the Asian countries, as well as in Australia. So what if you can, instead of sourcing plastic pallets, just create it from your own scrap, or fixtures to optimize storage and transportation of goods that are normally boxed and may have a big void in a shipping container. So you can put more stuff in a container, therefore, creating more revenue using, fixtures you make from your own waste that otherwise might be cost prohibitive to fabricate. And I'm optimistic and hopeful that there'll be case studies around this, because I think those are conversations that really get people talking and thinking about sustainable manufacturing in a new way.
Excellent, excellent. So this next question, I think we touched on a little bit as well. So I'm going to jump ahead and talk through. So the last question was asking a little bit more about is all plastic waste, and I think that we just touched on how some of it is, there's potential for doubling down and using it in unique and different ways. So here's a question. How useful is any of the trash recycled material that we find locally and abroad to repurpose it for new products? So how much can we actually avoid using brand new material for making products? I'll shoot that over to you, Samantha.
Yeah, I gave the city of Austin a earful last Sunday about this topic. So they had I'll use this as an example. They had a workshop around sustainability. It's really cool. Austin, I'll back up, has a commitment to be zero waste by 2050. We're still trying to figure out what that means. The great thing is the city has just been incredible in convening different groups to help inform their climate action plan, which they're writing right now. And I think it's transparent and online if you want to check it out, as well as the Zero Waste Initiative. Concurrent to that, which I find really fascinating, they've done a series of studies looking, and with other municipalities investigating this around consumer cities versus producer cities, and the amount of waste and plastic and different forms of excess that are either put into the landfills or emitted into the atmosphere in different communities. It's been really, really cool to watch. But what's interesting is part of our pilot in this conversation, we formed this relationship with the Habitat for Humanity Restore, where we're getting their excess waste. So in this case, reclaimed wood that has low value that's being sold for Habitat for Humanity. And we're pairing it with, ideally, we won a $10,000 competition called Reverse Pitch, waste that's actually coming from a manufacturing company in town that's putting 2,000 pounds of scrap into the Austin landfill every 10 days. And so we're taking that waste and we're working to grind it up at the Restore, and then potentially we'll be creating this furniture that will be paired with their own wood to then be sold and used for application. And what's interesting, I know this is a really myopic example, but we obviously have support from the city of Austin and different groups and in the school, and have been lauded quite a bit. But when we actually talk about, from either Habitat's standpoint or from ours, who we would sell the chairs to internally, everyone has great examples and says, the schools have to purchase a few thousand chairs next year, or the park needs this, and there's so much construction right now in Austin, or this business could really benefit from just this chair example alone. But the procurement doesn't allow them to work with a small business or this rated product. And even the city of Austin has said, I know it's absurd, we gave you $10,000 to do this and we need chairs, but we can't buy them from you. So I think from a manufacturing standpoint, it is a conversation that needs to be had. If you're going to encourage local production, you have to make sure that you have the infrastructure to purchase it, hopefully at cost too, especially if it's more than maybe what would be sourced in volume from an external supplier somewhere else. And providing those incentives and glide paths to not only provide the case study, but then to scale it locally. So I think that's a big facet that we wrestle with. And I think Austin and a few other cities are kind of the first. The Dutch are really good at this, and almost codifying it within organizations to say you have to sustainably source. And then you start to support an ecosystem of solution providers, whether they're making, the iRobots, or they're providing the components that the iRobot uses to help do that in a distributed way and to support each other, so that they get into those organizations. And all this kind of has to happen in concert. There's no easy answers.
Mm-hmm. Looks like we're coming up on time, but if people are fine with staying over a couple minutes, we can end on this question. And it looks like we have a few more. So maybe we start to we do a part 2 of this, because I find it very fascinating and very interesting topic to talk about. So Scott, this one came to you. What can companies ask to qualify if manufacturers have the capability to meet or even surpass green goals? So reduce waste, decrease energy, et cetera.
Yeah, so I think as we touched on before, the first thing is getting transparency. Like, even if the supply chain is terrible, you've got to have some sort of a benchmark to start from. So knowing from say a flowchart standpoint, what are all the different vendors that are required to go and produce whatever you're building? And in many cases, the supply chain may actually be branched, that you could have different approved vendor lists. So you may source your plastic from one of 3 different molding houses, and each one may have different capabilities from a sustainability standpoint in terms of the amount of energy they use, or how they deal with their wastewater, or just their overall scrap rate. But we look at, like, step 1 is just understanding and mapping out the supply chain. And then from there, you can go and measure it. And whether you're looking at waste or landfill versus recycling versus energy footprint versus, manufacturing, there's a lot of water often required. I know in some of the factories we work with that have had 100,000 workers. So it's pretty crazy to imagine that. But if you've got 100,000 workers, you need to provide 300,000 meals every day. And just thinking about what does that take from a supply chain, bringing in, if it's in China, the rice and the meat and the veggies. And, it's almost like a fractal. Like, you can, keep peeling back the onion, and new stuff shows up as you get more and more focused on it. But that's kind of how we're thinking about it. And then from there, once you've measured a thing, you can start improving it, or putting down goals that you want to hit as you move forward.
Samantha or Matthew, do you guys have any final words that you want to leave our listeners with?
I'll let Matthew give the parting shot, but I would say, and one thing I'm trying to do as a consumer when I unsustainably throw out my trash can is, I think we can all agree that every day, every year, we can try to be a little bit better. And you got to start somewhere. And how do you eat an elephant? It's one bite at a time.
I like that one.
I think the idea that this is hugely complicated, right? So, as designers and manufacturers and product development people, we understand that our work is complicated, but as you look at sustainability, this touches upon everybody's job, and everybody in the factory, and everybody in the supply chain, and all the consumers, and the stakeholders are hugely diverse, and the issues that we're working with are extremely complicated. And so we just keep that in mind. It's a big tangled web that we weave, but any little thing that we can do to educate ourselves on these processes, and educate ourselves on what's really happening before and after, and that cradle to grave situation. So that little bites of the elephant at a time.
Excellent. Well, I just want to thank everybody for participating and submitting such thoughtful and interesting questions. And once again, thanks to our panel of experts, Scott, Samantha, and Matthew. You're very insightful and helpful and informative for me, at least. And I know all of our listeners appreciate it as well. So we've actually recorded this, so don't worry if you missed any part of it. We'll be sending that out in the next couple of days. And if you have any questions, you can reach out to us at help@dragoninnovation.com. Feel free to check out Re3D on all their social platforms. They have a lot of great content and thoughtful, thought-provoking, interesting topics that they cover as well. So I think we have enough material here that we can recycle and reuse this this webinar as well. So I think that there's more that we can talk about for this subject. So maybe we'll run it back in the next month or so. But once again, thanks to everybody for participating. We'll catch you next time.